I'm joined now by Alex Gilbert, a nuclear innovations expert fellow and PhD candidate at the Payne Institute of Public Policy at the Colorado School of Mines. He's also the director at a nuclear startup. Alex, thank you so much for being here. Really appreciate it. So put this into context. How big of a breakthrough is this? What does it mean?
This is a significant breakthrough, and this really represents a number of innovations that have been happening in both the commercial and government sector for many years now. As you said, this has been the dream of fusion scientists for decades. What specifically happened here is that we were able to get more energy out of a fusion reaction than we put into it, and that is a prerequisite for any energy source. We need to be able to produce more energy from the use of it. This is a major change, and we expect to see things only accelerate in the coming years.
It's just incredible. What are the potential implications for climate change?
So if you look at our energy system right now, we have made significant progress for a number of things. We have more solar and wind online. But if you look globally, hydro, traditional nuclear fission, solar and wind are still only about 40% of power around the world. So 60% still comes from fossil fuels. And if you look beyond the electricity sector, the entire energy sector, it's over 80%. We need to decarbonize that. And even if we use all the tools that we have in our tool set right now, fusion is one more tool that can help us decarbonize more quickly, and it can also be used around the world so that we can help those emerging economies develop cleanly.
And I guess the big question on people's minds, because this is a breakthrough, but it's not yet being implemented in terms of an actual energy source, right? So how far away are we from that actually happening? Is it 10 years? Is it decades? What are you thinking?
Yep. So the specific breakthrough, we have yet to have the official announcement. If it is what we expect and what has been reported.
Important caveat there. Yes. Thank you.
It'll be net energy gain.
Yeah.
And that is something that has been done at a research facility, the National Ignition Facility. Now, that specific design is not meant to produce power. It's meant to show that the basic physics, the ability to do this general reaction is possible. Now, we need to use other methods that are being developed by an international project, ITER, in France, that the U.S. is partnering on, as well as commercial companies. Those are things that we will have to do demonstration projects over the next decade and a half to be able to get this to market. We need to be able to get not just energy out of the reaction, we need to get it all the way to producing electricity, which is a number of other steps we need to develop.
But you think that we could start to see this implemented practically as an energy source within a decade?
There are a number of commercial companies right now that are starting demonstration projects that will prove out their base technology. Those will be followed up by commercial projects that would break ground potentially within a decade. And the international project is set to also prove some of these principles out. It's something that if you were to ask people, say, 5 years ago, fusion was 30 years around the corner. Today, that's not the case. We could actually be relatively close to having it as a commercial source.
And help people understand exactly what fusion energy is. Is it cleaner? Is it safer? What specifically does it mean?
Yeah, so fusion energy involves the combination of atoms, lightweight atoms, to produce energy. It's the energy that we use that happens in stars. And it's really hard to combine atoms. They don't naturally want to come together. So you need conditions like a star, very high pressure, high density, high temperature, to enable it to happen. So for us to do that on Earth, we have to do a number of other innovations. We have to use specialized facilities. But if we're able to do that, it has a lot of opportunities. First, the fuel. We can actually use water that we've processed and do several things with to make that fuel. So it's not a fuel-constrained resource. It is something that the technology you can build out. It doesn't have some of the same concerns as fission. So when you're actually looking at this, there's not any concerns about, say, a runaway chain reaction, any sort of those type of safety concerns. It could just be something that you don't have the same safety cost associated with other sources of energy.
Okay, and what are the potential roadblocks? Because as you say, this is a hugely significant moment, and yet there's still a long way to go, right?
Yes. So the specific technology that is being used here at the National Ignition Facility uses laser inertial confinement fusion. What that means is that you just use very high-power lasers to push the fuel together. Now, that technology we actually don't think will be the one that is commercialized. There's other technologies that are focused primarily on using magnets. So we actually need to develop a whole new technology path to be able to get to something that can produce energy. Then once we've done that, the ability to convert that energy into electricity is a big challenge. The energy that's produced is in the form of the kinetic energy of the charged particles. Capturing that and converting that into electricity involves multiple steps that we don't have. And even though the fuel is abundant in the long term, it is a specialized type of hydrogen. So we need to develop the fuel cycle to be able to do that. That is something that is eminently doable, but it will take time and it will take cost. And if we're talking about the urgency of climate change, we need to get started on that now to make sure that those supply chains are available.
And just very quickly, if this is the announcement we're expecting from the Department of Energy tomorrow, what do you hope people take away from this moment?
I believe that this is a potential inflection point in the future of fusion energy. This is no longer a future energy source that is conveyed to the realms of sci-fi. This is actually something that is tangible, that deserves investment. Commercial companies have raised almost $5 billion in the last several years for their different approaches. This needs more money from a public and private perspective, but this is something that the entire grid can benefit. We can see this technology come to fruition if we put the will behind it.
Okay, well, this is complicated stuff, and you helped us to understand it a whole lot better. Thank you so much, Alex Gilbert. Really appreciate the great information.
Thanks for watching our YouTube channel. Follow today's top stories and breaking news by downloading the NBC News app.